All right, second page. Compound interest, half-life, growth and decay. Compound interest. Suppose you deposit the same $1,000 in the same college fund paying 7.2%, but now it compounds what's called quarterly. Is that different? Before you only got interest how many times a year? Once. But this is compounding quarterly. So that compounds your interest how many times per year? 4 times per year. Does it give you 7.2% each quarter? It splits it up into fourths. So we have to figure and think to ourselves, what's 7.2 divided by 4? Can someone tell me what that is? 1.8, Brett says. So really I have 101.8% done every, how often? Every quarter. Do we understand, John? That's every 3 months. Okay, so my B value is 1.018. So here we go. Equation. Who can give it to me? Jalan.
1,000 times 1.018 x.
Okay, excellent. Good start. This is where the problem changes a little bit into more realistic stuff. And Sam, 5 years, right? How many quarters in 5 years? 20 quarters in 5 years. Do you see that difference? The interest rate decreased, but how many times are we going to compound it? Not 5, but 20. So, off to the side here, I want to say x equals 5 times 4. Put a little note there that says quarterly, because later you're going to forget how to do this. So x equals 20. So everyone, let's figure this out. Now, before we punch it into our calculators, do you think you're going to end up making more or less?
Same.
Or same? All right, let's see. Plug it in. 1,000 times 1.018 raised to the 20th. 1428.75. What was the amount on the previous page? 1415. So we made how much more money? Yeah, $13. How did we make more money? The exponent is the same. Still 7.2%. Yeah. Let's say after the first quarter you have $1,000, you get paid $1 after the first quarter. After the second quarter, what are you earning your interest on? 1,000? No, 1,001. Versus the first scenario, you had to wait a whole year to get the interest paid to you. So in the first quarter you make extra money, in the second quarter you make money on the first quarter, in the third quarter you make money on the first and second quarter, and what happens over the course of 5 years? We made an extra how much money? $13. Okay? Now, could you do this also monthly? Instead of dividing by 4, you divide by 12. Get a smaller number here. But here, instead of multiplying by 4, you would multiply by 12. So you'd get a higher number here. Do you think monthly would be even higher?
Yes.
Yes. Not a ton, but more. Okay? Josh? I did. Good pickup. All right. Half-life. A certain synthetic substance called worium has a half-life of 6 hours. Suppose the lab has 80 milligrams of worium. How much will be left after 24 hours? After 48 hours. Here's how we set this up. Half-life. Instead of multiplying by 100% plus the interest, what's our multiplier? What's the word half? Right? 50%. And so 50% as a decimal is 0.50. Okay, so y equals How much do we have to start with? 80 milligrams. What's my multiplier? 0.5 or 50%, because a half-life equals 0.5. And I'm raising it to the x. So what's my first scenario? 24 hours, right? What's the half-life? What does it say? 6 hours. So how many times is this going to occur? 4 times. So I raise it to the 4th. So plug it in. 8 times 0.5 raised to the 4th. Oh, thank you. 5. Sorry, it took me a second to catch you.
I got you.
Did you put?
Oh, yep, I did it to the 5th.
All right. Is that my correct answer? What do you think?
No.
Who said no? Why no, Josh? Has to have milligrams. So after 24 hours, 5 milligrams. Now, what do you mean?
Like, do you even have to put it in like a severe?
It's an unstable substance, and it breaks down naturally. Okay? Chlorium is an unstable substance, and it breaks down naturally. Katie?
On like a quiz or a test, are you going to tell us like what problems are half-life and what problems?
Yeah, if you see half-life, that's a key to know it's 0.5. And I'm going to tell you all this information. Now, from this information, you need to say, oh, that's an increase, that's a growth. Oh, this is a decrease, that's a half-life.
Okay.
True.
So, like, I don't think they just the test you're going to give us like all the last statements?
Yeah. These?
Yeah, like we don't have to write our own? Or we could...
No, I'll just give you the top half. I'll just give you the problem. You'll need to remember, oh, that's A times B to the X.
Yeah.
Is that fair?
Yep.
So, all right, here. Let's try our other one. 80 times 0.5, and this is my 48 hours one.
So would it be
How many half-lives in 48 hours? 8. How'd you get 8, Jalan? Okay, 48 divided by 6 is 8. How much worium is left after 8 half-lives? Did someone confirm that?
Yep.
0.3125 milligrams. This stuff disappears pretty quick, doesn't it? Okay, so that's an example of what's called half-life. Josh, question?
Would you know, like, attach to their content for commercial steps or just be
It would be good for me to see this equation, because this equation illustrates to me that you have demonstrated the knowledge that you need to have. From here, you can go right to the answer. So, yeah, so our question is, can we just show this? I would like to see this, because this demonstrates to me that you've shown it. Up here on the interest one, I would like to see this interest. All right? How did you get that 1.018? You know? That might be good to show off this side in a very neat scratch work. All right, so down here at the bottom, I have 4 different equations. I want to just identify them as growth or decay. Now, before we even identify, I want you to focus on the equation A times B to the X. Remind me, what is the A? What does that represent? That's the start. What's the B? The multiplier. Now, in terms of growth and decay, am I going to focus on the starting point or the multiplier? The starting point makes no difference, right? If it's growth or decay, that's all factored based on the multiplier, that B. So let's look at this first one. See that 0.5? That's the multiplier. Do you think this thing is going to grow or decay? It's going to decay. All right? It's going to decay. Let me show you what this looks like. See if I can do this for you. Clear that out, clear that out. 5 times 0.5 to the x. Here's what that looks like. What's happening to this function? It's starting and it's doing what? It's decreasing. Is that obvious decay? Now, did I need to graph it to show the decay? Right there shows the decay. 0.5, it's decay. But that's what's happening to it. By the way, is that touching right there?
No.
If you zoomed in, what would happen? Yeah, so we go to zoom. We go over to there. We zoom. Oh, look. What do you see there?
It's right above.
Okay, let's arrow over. It looks like it's touching right there, right?
Yeah.
We zoom in. Or maybe I gotta hit zoom again. And see there's still space. But now I want to show you something. You see the numbers down here at the bottom? Y equals 0. Y equals what? 0.08. How much space is that? Itty bitty space.
Why did back there say y equals 0?
Because that's the position of see that little crosshairs?
Oh, I see.
That's where that crosshairs is. So it's just telling you where you are. All right? So, anyway. So, obviously this is decay. What about the second one, 0.68? Do I care about that?
No.
That's the what? Starting point. What's the 2? That's the multiplier. So what do we have here? Growth. Look at the next one. It's 100. So it's growth, right?
Nope.
It's 2/3. So it's decay. Is this a half-life? No, it's a 2/3 life. Whatever that is. Every so much of a period, you only have 2/3 of what you started with. Okay? So this is decay. 5/6, 1.02. That's growth. Because this number is greater than 1. Identifying growth or decay. Is there any work? No. If I asked you for the reason, what I would want you to say, Luke, in terms of supporting reason, it is growth because the multiplier is 1.02 and that is greater than 1. So that would be your critical analysis. And so if I say, give me the reason why, talk to me as if you were teaching me. Josh, question.
We just use like the word b for multiplier.
Use the word what?
We use the letter b for multiplier.
The value of b, which is the multiplier, is greater than 1. Use verbiage that would be very clear. So it's never a question about what we have. Make sense?